Right, so good afternoon, everyone. So welcome back to Plan 258. Okay. Our agenda for today will discuss about three things. This is the part that we will discuss, supposed to be discussed last meeting before midterm. So about IFN prioritization, okay, which is part of MCTM. And then we will start with the new topic about decision analysis. So we'll talk about how people make decision and then decision uncertainty. Okay. And then putting these three together, I hope you can see the contrast between the three technique. Okay. So let's start with the first part, which is okay. Decision. Can you see my slide? No?
Sir, it's in presenter view.
Oh, really? Wait. Oh, okay. This is wrong. I'm supposed to put it here and schedule and can you see the slide?
Still in presenter view, sir.
Still in percent. Apparently, this is the script too. Okay, in that case, okay, this one then. Is that okay? Yes.
Yeah.
Finally. Okay, so this is the first topic. Okay, so ideal flow network for prioritization. Okay, so in this topic, we will discuss how are we going to use ideal flow network to compute for task or project prioritization based on multi-dimensional data. Okay, so how to determine the weight of the data from the data and then determine the subject priority or the project priority from the data. And then we will touch a little bit on the theory, okay, based on the relationship between IFN and what is called reversible Markov chain. Okay, so yeah, I know that we can use IFN or ideal flow network for many areas, including transportation, political power. We learned about that last time, and then also artificial intelligence. But I was asking a new question. Okay, is it possible to use IFN for project management, for decision analysis, for multi-criteria decision making? Okay, so here it is. Okay, so we are able to do this. Okay, and let's explore how IFN can be adapted. Okay, to prioritize the task and project based on table, multi-dimensional attribute. Okay, so what is that, the table? So the table data is something like this. Okay, so you have just two-dimensional data. Okay, on the row is subject. So the subject can be the task, can be the projects. Okay, and then in each column you have variables. Okay, so you will have n variables and m subject. Remember, yeah, subject can be task or projects or any subject. Yeah. So now our purpose is to use IFN or ideal flow for prioritization. Okay. So before that, let's think about how are we going to use what is the meaning of one-dimensional data, two-dimensional data, and so on. Okay. So Here we have data table. So you see here is not a project, but the name of the store or the name of certain store or certain business. Okay. So and these are the revenue and the cost. Yeah, so there are two attribute or the factors, okay, revenue and the cost. Okay. So if the two variables or the two attributes here are actually related, okay, they are dependent on each other. So and they have the same unit, we can derive a new variable, say name it profit. Okay. So then you can put them into one dimension, yeah, only one variables. Okay. Now, if they cannot be put into, say, for example, this one, yeah, two variables are actually independent, like the effort and the actual value for the task. Okay. So then you cannot put them as a new variables. Okay. So in this case, you still use them as two-dimensional data. Okay. So the number of dimension represent the number of variables that you use. Okay. So here is example that we will use later. Okay. So how many variables here? So you have 5 projects and 1, 2, 3, 4. Yeah. So in this case, we call this a 4-dimensional data. Okay. And look at this. Effort is actually inverted, like cost. Right? The less is better. Okay. The other variables are similar to gain. So the more is better. Okay. So more resources is better, and so on. So you can start to see there are two types of variables. One is inverted, that means less is better, like cost. And the other one is just a normal variable, but the more is better. Okay. So these are example of 6 dimension. Yeah? So if you have a sport tournament, you can have this 6 attribute as your dimension. Okay. Similarly, if you are using another data, okay, these are the name of 6-dimension data for web ranking, web page. Yeah. And some of these are actually inverted. So you need to identify which variable is inverted and which one is just normal variable, which like gain. Yeah. Inverted is like cost. Okay. So next is, this is the steps to do IFN prioritization. Okay. So you have the data table here. Okay. So you have the data table. Okay. And then what you are going to do is first you normalize each attribute. Yeah. So you make it into score. You normalize each attribute. Okay. And then from each attribute you compute the probability. Yeah. So this is the weight, basically. So from here you can also going down to compute the priority if you want. So and then from there we can go to the next step. That is to aggregate the subject, yeah, into score. Yeah? And then you calculate the utility, yeah, of each subject. Okay. After that, you compute the probability as the priority. Yeah. So this is the usual way to do. Yeah. So this one you can also go in here. But this is the final result is this one. Yeah, the one in the subject priority is the final result, right? But you can also use this probability to compute the stochastic matrix and then compute the ideal flow. Okay, and then from here you can get back, yeah, the priority. Similarly, if you know the subject probability, you can compute this as the stochastic matrix and then calculate the ideal flow and then come back to get the subject priority. So basically, the subject priority is can be computed different ways. Yeah? One is using the fastest way, this one, okay, going here, or you can also use it IFN. Okay, so the IFN is actually optional. Okay, so there I put it there. Yeah, so first the goal is to prioritize. So you have M subjects, and then you have N attribute. Okay, so what to do? You normalize each attribute. Okay, and then after that you compute the probability of each attribute. Okay, and then aggregate the each subject. Okay, for each attribute into score, and then compute the utility, and then get the priority. Yeah. So optionally, this last step is optional. So the IFN step is actually optional. Yeah. To compute the stochastic and IFN itself, you can also get this. So based on these optional steps, then you can start to see the theoretical connection, yeah, between IFN and prioritization. Okay, so let's start with a simple example. Yeah. Oh, what happened? I lost. Let me. Okay. Can you see the slide? Not yet.
Not yet, Doc.
How about this time? Can you see the slide?
Maybe, sir, in the presenter view, sir.
This is strange. Share again. Why I cannot see them? I keep making problem with this. And it detected as the second screen here. This is strange. Anyway, let me see. Oh, this one? No. Okay, let me share the screen one then. Okay.
It's okay now, Doc.
Yeah, okay, cool. The name of the screen is reverse. Okay, so let's come on. Okay, so first you want to normalize the value. Okay, so for each attribute you want to normalize the value. So normalization depends on whether your value is similar to gain, which is the higher value is better, or inverted. That means the lower value is better. So this is similar to cost. So we already learned this last time. So you can normalize easily. So you have gain minus the minimum, and you know the maximum minus the minimum. So you will get the normalized value. Okay. So if the value is inverted, similar to this formula, all you need to do is just 1 minus. Okay. So let's go to the example so that you can see. Yeah. Suppose this is a cost. Okay, so you have 3 projects, A, B, and C. Okay, so the cost of 3 projects is 3 million, 5 million, and 2 million. So of course, the minimum is 2, maximum is 5. Okay, because this is cost, so inverted. So then we use the second formula here down. Okay, 1 minus. Okay, so 1 minus the CA minus the C minimum, and then C max minus C min. So let's plug in the numbers, then you get these 3 values. So is it clear? Okay, so now if your next, if your value is actually revenue, so this is the normal, so that means gain, right? So say the same number I put here. So A is 3, 5, and 2. What is the normalized score? Okay, the normalized score now become 1/3, 1, and 0. Can you compare with earlier? So 2/3, 0, and 1. Okay. So with this, you can start to see if, depending on the attribute characteristic, okay? So if this is inverted or not. So then you normalize, okay, using one of these two formulas. So up to here, is it clear or not?
Clear, sir.
Yeah, thank you. So next, this is starting. Okay, so then this is the normalized value. Okay, if you put that n a while ago in the table, so because table have 2 dimension, so this is the normalized value. Okay, V in here is actually the normalized value. Okay, I and J represent the row and column. Remember, the attribute is always in the column, subject is always in the row. So now what you need to do is you sum over I. That means you sum over all the rows. Okay, then you will get the score at the bottom and of each column. J represent the column. Okay, at the bottom of each column you will get a score. Okay, and then you can calculate the probability of each attribute of this. Okay, I proposed 2 methods. Yeah, so you can use softmax function, this one, or you can use simple proportion of this score. Okay, so I will show you in the example, so you don't need to worry. Okay, so the probability is basically the normalized weight of each attribute. Okay, let's start with, and because this is a probability, so the sum is 1. Okay, sum of probability is 1. Can you distinguish the W here and the omega notation? Okay, so this is W represent the score, omega represent the weight, okay, normalized weight or the probability. Yeah, so let me show you an example so that this is clearer. Is that okay? So I put the same number a while ago that we already computed. So the cost a while ago was how much? 2/3, 0, and 1, right? So this is the actual data, yeah? 3, 5, and so then we put it here. Okay, 2/3, 0, and 1, and then 1/3, 1, and 0. Okay. So, and then what happened? We want to compute the score of each attribute and the probability of each attribute. Okay. So the score computing by adding the normalized attribute over the row. Okay. So this one is 2/3, 0, and 1. So you get this value, okay, 1 and 2/3. Okay. And then 1/3 and 1. So you get this value. Okay. 1 and 1/3, right? So now we want to compute the probability. Yeah. So how to compute the probability? Easy. One way is to compute based on proportion. Okay. So how to compute proportion? Easy. This value I put here, okay, divided by the sum of this value, right? So 1 of 2/3 plus 1 and 1/3. So then you get 5/9 and then 4/9. So you can get that. Okay. Of course, the sum is 1. Up to here, is it clear or not? To compute the this is, what is this? This probability represents the weight of each attribute. Okay, this probability represents the weight of each attribute. Okay. So how if I don't want to use the proportion, but I want to use softmax? Okay, so if you want to use softmax, Okay, look like complicated the formula, but actually not. Okay, let's assume beta is 1. So then we can compute that, right? So we have the same value here. Okay, but now we want to use softmax. Okay, this is the formula of the softmax function. So then all you need to do is beta is 1, so you don't need to care about that. So you have exponent of this one, yeah? This is 5/3, right? And then this is like 4/3. Is that correct? So then what you need to do is instead of just proportion 5/3, okay, but now you exponent first. Okay, you exponent first. Then you get different value. Okay, because you use exponent, you get different value. You can compare. Earlier we have how much with the proportion? 5/9, yeah. Now with the softmax, you get 4/7. Yeah, and 3/7. Yeah, the sum is still 1. Okay, so the probability is not the same. Okay, so which one you will use is up to you. You decide on your own. Okay, for me, each have own merit. Yeah, so softmax you have parameter beta here. That means you can adjust the value of parameter. Yeah, to get something that you want. Okay, for example here, what happened if I change the softmax function with beta not 1, but now become -1? Okay. Can you practice this so that at least you can have some practice? So use this, okay? The difference is now beta is -1. This slide is in Moodle, so you can start to follow. Just do this simple practice. What happened if beta is -1? What happened if beta is so that yeah, all you need to do is to input these 6 numbers and then get the sum. Okay, and then start to compute the probability. You get it? Any question about this or? So if you change the value of beta, okay, to -1, right? So there, can you see? Now this one exponent of minus, the same value as earlier, but this one now become negative, okay? And the probability is inverted. Can you see that? The probability is now inverted, yeah? This cost is no longer now compared to the earlier when beta is 1. Okay? Can you see this? In beta is -1, you get 3/7 and 4/7 there. Okay? When beta is equal to 1, you get 4/7 and 3/7. So it's the other way around.
Other way around, Doc. Sorry, already question.
Yeah. So you get in reverse. Okay. So this show the flexibility of the parameter. Okay. So in fact, what you can do is, what happens if beta is 0?
They are all equally important, sir.
Equal,
Yes, very good. So
50-50.
50-50. Yes. Okay. So with that, you can, yeah. The value of parameter. Now, my question. Can you make the beta so that the same as the simple proportion? What is the value of simple proportion a while ago? This one. Can you see? This is the simple proportion, right? With this 5/9 and 4/9. Okay, so if you calculate using simple proportion, this is the probability. Now, my question is, which one is more general, the simple proportion or the one with softmax? Of course, the one with parameters should be more general, isn't it? So if this is more general, then that means I can always get back the simple proportion simply by changing the value of beta. Correct? So that's why if you want simple, okay, so you just use simple proportion like this. But if you want flexibility, okay, then you probably want to do using softmax. Okay, I hope you understand the meaning of why we want to complicate the matters by using softmax, right? In fact, this is the one that we use in neural network, and also in logistic regression, right? But the question is why? Okay? So because using this, now you have the power to change the value of beta, okay? And then you're supposed to get back this simple proportion value by simply by changing the value of beta. How much? How much is the value of beta so that I can get this back? Oh, beta -1, yes, win. But okay, that's good. So how about the next discussion? So what is the value of beta so that the result will be the same as the simple proportion? You can keep changing that, or what is the better way instead of doing manually? Any idea? You can use
Logarithm.
Goldseek, or you can use sulfur. Okay, so the clue is to use solver. Okay, so you already know the simple proportion value. Okay, 5/9, 4/9. Okay, and then you minus, okay, with the value with beta, so that you can get the sum square of error. Yeah. So, and then you want to set this to 0. Possible? Okay. So when you set this to 0, what will happen? You will get the value of beta. Okay. Fine. Oh, here it is. Oh, can you see my Excel?
Yes, sir.
Okay, so this is the value of beta. Okay, there. So this is the simple proportion that we have, right? So this is the data that we're supposed to get. Yeah, so this is the total is 3, so the simple proportion is simply 1 divided by that, right? So now beta is just exponent of this value, okay, the one that this is the data that we have. And now earlier you set beta to be 1. Right. So this is what we get, 1. So this is the value that we have, right? 4/7 and 3/7. So this is the result. Okay. And now I want to get what is the beta, okay? So that this proportion is the same as that proportion. Okay, so then I set up, okay, that the 2 proportion I will just minus and then square it, okay? And then the same thing here, and then I take the sum. So this is the SSE, right? Sum square of error, isn't it? Okay, so when I put beta 1, this is the sum square of error. So then what we do? Of course, simple, yeah, just solve for. Okay, so we set this value to be 0 here. Can you see that? And then what do we want to change? Of course, beta, yeah. So then just solve it. So we get the solution. So this is the value. That's what 66. You see? And then based on that, you can also create data table. So we start with copying this. Okay. And then this is the copy of this value, the proportion. Okay, the same thing. This is the proportion, the second one. Okay. And then you start with any value. Say I put here 25. Okay, and then we just add 0.1. Okay, and then we hold this. Okay, shift and down. Okay, so until the bottom. Okay, shift and up. Oh, shift and up. Okay, so then you hold the whole value here. Okay, so this one, shift and down. Okay, so you highlight everything. Okay, and then you go to what if analysis data table. Because this is actually you want to have it in here, okay, in the second part. So then you go put this value to the beta. Okay? And then when you click, you can get that value. Is it clear or not? Okay, if not clear, I will put it again. I will delete this part. Shift down. Okay. So I delete this so that you can see. Okay, all you need to do is first you put this in beta. Okay, and then this the second is the proportion here. Okay, and then the third is in the second proportion. Okay, and then here you set value. Okay, say minus 25 like it here. And then the second one, you put plus 0.1. Okay, and then you copy it up. This value you copy it up. Okay. So after that, what you need to do is to highlight. Yeah, so you highlight everything here until here. Okay, and then go to what if analysis. Yeah, data table. Okay, and then because this is beta that you want to know, so you go here, you set as beta. Okay, this is how you do sensitivity analysis. Yeah, and then click OK. And okay, and of course after that you chart. Yeah, so with this, actually, you can also find what is the value of beta in order to get this proportion that you want. Yeah. So the value of beta can be anything from minus infinity to positive infinity, but I think above or below 25, minus 25 and above 25 is practically almost the same. 0 and 1. Okay. Okay, so up to here, is there any question about this softmax function? Is it clear? Very clear? Okay. So good. So yeah, so we get this value. Okay. So what happened to when probability beta is 0, that means equal, right? Exactly in that value. Okay, so when you do sensitivity analysis, you will get this value. So when beta is 0, this is exactly 0.5. This is the intersection between the two values. Okay. Okay, so once we get this, the probability of the attribute or the weight of the attribute, now we can continue, okay, to aggregate the variables, okay, by computing the next step, which is computing the utility of each subject, I, okay, based on linear combination. So this is the weight a while ago, and this is the normalized data. Can you see that? And then we just sum over each column. Okay. So then this is called utility. Okay. So let me show you with the example, continuation of a while ago. So we have this probability a while ago. So I use simple proportion. So we have 5/9 and 4/9. Okay. And let's compute the utility of each subject. So to compute the utility of each subject, so you just get the probability multiplied by the value here. So 5/9 multiplied by 2/3 plus 4/9 multiplied by 1/3. Yeah? So then you get this value. So these are the utility that we can get. Is it clear? Okay, this is the next step. Yeah. After you get the probability of each attribute, so now you compute the utility. Okay. Now, after you get the utility, then you can calculate the probability. Again, at this point, because this is utility, so you need to use softmax function. Yeah. So I have another parameter here, gamma, okay, which is by default equal 1. Okay. With that, because you already know the utility, all you need to do is to compute the using softmax function. Yeah. Then you can get the probability. Now, because you know the probability, then you can actually run them. Okay, the highest probability C, so on. But this is interesting because if you look at the data, okay, if you look at the original data, okay, they are exactly 0 in terms of profit. Can you see that? Okay, the original data of these problems was in the initial here. Okay, the cost of the project is 352 and then the revenue is also 352. That means the profit are all zero, right? But we can still get the priority based on zero profit. This is something that I wonder. Okay, so we can still, because we compute the probability, okay, so we can start to see they are actually difference. Okay, up to here, is there any question? So done. After this, you can calculate the power if you want, but this is optional. So this is the final result, right? Our goal is to prioritize, so we get the run of the project. So you will do project C. Is there any question? If not, so can you practice using this one? This is the one that you do last time using knapsack. Do you remember? So you have effort and value, so, and you have 5, 6, 7 tasks. Okay, this is clearly 2D. A while ago was actually 1D data, so this is 2D data. So you can compare this with the result of knapsack last time. Okay, so what you will do, first you normalize the value. Okay, so you get the value and then you normalize. Okay, from this data you normalize. Yeah, this is the normalized value, and then you get the sum, right? The score, and then you get the exponent, and we normalize the weight. Yeah. Okay. After that, you can compute the utility and okay, and the probability, and then find the run. Can you practice first? This is the problems. And once you finish, you probably want to share your screen. Okay, so I will stop my share screen. When you're done, you can share your screen. Then I'll share my screen.
Sir,
Hmm?
can I share my screen?
Oh, sure. So
Is it showing now?
hmm.
Okay, so first we normalize the values.
Mhm.
Effort is a cost
Hmm.
variable, so it's 1 minus
Mhm.
its value divided by the minus the minimum all over the maximum minus minimum.
Hmm.
Then the value is again variable. So
Correct.
you use the other formula.
Yeah.
It's the same as the one in Moodle.
Yep.
Then we sum
Okay.
W sub j. Then you get the softmax function
Yes.
by taking the exponent with beta and gamma equal to 1.
Right.
And then uh, you take this one, the exponent of beta to the in W sub j divided by the sum of each for each variable.
Yep.
So you have this omega
Yep.
totaling to 1, 0.53 and 0.46.
Yes.
Then you get the utility function as some product of the normalized variable
Mm.
and then the omega.
Yep.
Again, we sum, and then similar to the softmax function with beta and W, you get now the softmax function of the utility.
Yep.
Again, using gamma and the utility values, sum it again, then you get the probability the same way as we did with omega sub j.
Yes.
So for each task, you have this, and then just follow the in Watson model. We have this ranking.
Yes. So excellent thing. Okay.
I'm missing still the knapsack one.
Ah,
Do I still need to do the knapsack, sir?
no. Last time we did it last time. So in the knapsack one was actually better than this. Okay, actually it's different problem anyway. So using IFN, there is no constraint. Okay, so you get A, C, G, E, F, right? This one. Okay, so these are A, and then C, and then G, and then E, and then F, correct?
Yeah.
Right. So, but using knapsack solution, you have a constraint. Okay, the maximum effort hours is the constraint. For example, 10 hours only. Okay, so in that case, you will set a constraint there, but the maximum is actually 10. So this is so the objective is to find the sum product between the value and the
And the effort.
yes, and
No.
the x is, you can add here new column x, okay, which is either 0 or 1, so you can put it 1. Yes, and then at the bottom you can put the objective there. Okay, objective is some products between the value and x. The x and the value. Yeah. And then now you have a constraint, okay, that you set. So this one, for example, so the constraint is the sum product between the x and effort. Okay, then this one must be less than or equal to the given value that you want, for example, 10.
Sir?
10, for example, or 8 hours. I don't know how many hours in a day you will work.
Well, let's say, yeah, 10.
Okay, let's put 10. Okay, so then you solve for. So go to the
We maximize the objective by changing.
the solver is to maximize the objective by changing x subject to constraint. And then additional that x is binary. Pin. Yes. And then click OK and then run. Solve. Yes.
We get a C,
29. That's
E,
correct.
E, and F.
Yes. Now you get different task prioritization, okay, which is based on constraint. So in this sense, actually, an abstract is better than the IFN, okay, because it has more constraint. But if you have no constraint, so you can use the IFN.
Right.
Right.
Thank you, sir.
Yes, very good.
Maybe I need to ask again on this data
On this one,
table.
okay, so
Yes, sir, on
go.
the data table.
Okay, so number one, can you get the beta? It's 3 equal to, where is your beta?
This one.
That one, okay. And then where do you get the proportion? That,
Here.
okay, that one is I. Can you? Okay, that one equal to, okay, that's correct. Okay, then you just need to highlight from H3 down, okay, until the end of the table. Okay, there.
Okay.
Okay, and
And
then you
do the
go,
what if analysis.
yes, data table. Because, yeah, now, because you want to do column, so you go to column input.
Column. Okay.
Yes, column input, and then click to beta, D10.
This one. Okay.
Yes, and then click OK.
Oh.
Yeah, miracle. So this way you can do sensitivity analysis. You can create a table. Without this, you need to compute very long to get this data. And then now next is just to plot. Okay, but because your value is actually between 5 to 5, you will get the plot is linear. You can try. Yes.
Yes.
So, yeah, almost linear, right? So if you want to get it more non-linear, so the value, the range of the value or the beta value, you can make it bigger. For example, from 20 to 20. Yeah.
Yeah.
That easily you can use. Instead of 0.1, you can plus 1, for example. So start with minus 20 on the top, and you just change, no problem. And then that one is plus, no, plus 1. 1 plus the earlier. Equal 1 plus, no, equal. Oh, okay, you want to drop that. That's okay. And then you can copy down. There, you get it more non-linear. Yeah, anyway, just rearrange.
Okay, thank you, Doc.
Yeah, thank you. So how about the others? Is it clear or not? Yeah, thank you, Vin. Anyone once more want to share screen? Is it clear or not? Okay, so let me add one more example, but this time comprehensive. Is that okay? Seems. How to do is. Oh, this one. Can you see my slide? No?
Yes, sir.
Oh, okay. So again, let's get the comprehensive example for all. So we get a data table, right? And then you calculate the normalized score and attribute probability. Okay. And then you get the priority there. And then you can get the subject probability, subject utility, and then probability, and then priority. Yeah. A while ago, this is what we have. So let's do that. Okay. So now I have, instead of just 2, now I have 4. Okay. So 4 variables here. Okay. And we have 5 projects. Okay. So what we will do is effort is inverted. Okay. And the other 3 are just the normal, similar to gain. Okay. And we know the minimum and the maximum, right? So this one, the minimum is 2, right? The maximum is 7. So there, I put minimum and the maximum for each column, okay? And from here, we can calculate the normalize, yeah? So this value, I can normalize, yeah? So of course, the maximum, and because we normalize, the maximum will become 1, yeah? If this is gain, and the maximum will become 0 if it is cost. Can you see that? So this is the maximum cost, 7, so become 0, right? So if it is gain, okay, the maximum is 5, right? So it will become 1. Okay. So this is multiple criteria, yeah, multiple attribute. So then we normalize first. That's the first step. Okay. And then second step, we sum, okay, each attribute into score. Okay. So we already normalize. So what you will do is you sum at the bottom. Yeah. So this is the score. So let's call this WI. Yeah, this is the score. And then what you will do is, because we know the score, okay, we can calculate the weight. Yeah, so normalized weight. So I use softmax function. Beta is equal 1, so I can get this is the score. Okay, and then now we use we want to get the weight. Okay, so how to get the weight? You put only the nominator here. Okay, the nominator here you compute. So exponent of 2.8, you get this. Exponent of 2.5, you get this, and so on. Okay, and then you get the sum, right? So what is this sum? This sum represents the denominator here. Okay, so then the weight is easy. This one, okay, 16 point something divided by 60, so you get 27. Okay, so 12 divided by 60, you get 20. So, okay, so now becomes simple proportion. Yeah, after you compute the exponent, you will get simple proportion. You see? And next step, you aggregate the all attribute, okay, into utility. So now you already have the weight for each attribute. Okay, you just copy from here, right? The blue one. Okay, and then what you need to do is you multiply. Yeah, so 27 point something multiplied by 0.7 plus 20 plus point something multiplied by 0.75 plus 25 multiplied by 0.525, and then 27 multiplied by 0.4. So you add all of that, that means sum product. Yeah, this is how you will do. In Excel, you will just use sum product, yeah, of the normalized factor weight and then the normalized subject. Yeah, and then you will get the utility. Okay, for each row I. Okay, so look at this. I mean row, J mean column. Yeah. Okay, after that, okay, what you will do, you compute the probability based on utility. Yeah. So if I know the utility, so I want to get the nominator here. Yeah. So then I compute the nominator first. Okay. And then when you sum this all of that, okay, this represent the bottom here, the denominator, okay. After that, what you will do is simply this one divided by the sum, yeah, you will get the probability, okay. So now if you already get the probability, then of course you just run them, yeah. So as simple as that. So you can just run them. Now you can also similar to the IFN power last time, so you can also divide by the minimum, yeah. If you know the probability, you can get the minimum of the probability, and then so the minimum is here, right? 15. So then everything divided by this minimum, you get the power. So up to here, is it clear or you have question? So based on this power, you know that this project, okay, which one is the highest? This one, yeah, number. Project P is the one that we choose, isn't it? If you need to choose one, so you choose project P. Yeah, which is actually 1.5, so 54% higher than the lowest, yeah, project 5 in terms of the power. So nice. Okay, because you get the probability, okay. Instead of just utility, now you get the probability. So based on the probability, you can get the power. Okay. Any question? Is it clear or not? So now I want to touch, okay, what is called 1D stochastics. Okay. Now we want to relate this computation with IFN. Okay. So the one in this part, yeah, the one in the white part here. Okay, the one in white part here. So you already have the attribute probability, you already have the subject probability, right? Then from here you can easily compute the stochastic matrix, yeah. And once you know the stochastic matrix, you can calculate the IFN. Okay. So how to do that? Okay, let's see that. So this is just copy a while ago. Okay. So the next step is actually the IFN step. Okay. So how to do is you use that probability, either the subject or the attribute, and then you put that into 1D stochastic matrix. Okay. And then from there, you calculate the IFN. Yeah. And from the IFN, you can calculate the priority. Of course, the priority represented by the sum of row or the sum of columns of the IFN. Okay. So let's see this. Because now you have two probabilities. Yeah. One is for each attribute. Okay. The other one is for each subject. Right. So how to put from probability, which is one dimension, into stochastic matrix? Easy. All you need to do is just repeat the first row n times. Yeah. And here you repeat the first row m times. Okay. Remember the number of J here, the number of columns, okay, is 1 to n. So in that case, you repeat the first row n times. The number of subject is 1 to m. So in that case, you repeat the first row m times. Yes, as simple as that. Okay, let me give you an example using that comprehensive example a while ago. So in that step 2 a while ago, so we have the probability of each attribute. So this is each attribute. Can you see this? This is the probability of each attribute. Okay. All you need to do is copy. There. Can you see? I just copy this exactly. In the first row. And then after that, I copy again. Exactly. Down. Can you see? So this is 1D stochastic matrix. One dimension stochastic matrix. So I just copy for all the rows. One row to all the rows. Is it clear or not? Yeah. Similarly, now this is for each attribute, right? So how about for each subject? Yeah. Remember, each subject now you have 5 projects here. Okay. This is the result a while ago. So what we will do is, of course, because this is in the column, so you need to transpose first. Yeah. So you transpose, okay, and then you put it in the first row. You put it in the first row. After that, what you will do, repeat. Yeah, you repeat the first row m times. Okay. So once you repeat this, what you will do, once you get the stochastic matrix, what you will do, you compute the IFN. Yeah. So this is the IFN. Because you already have the add-ins, so you can use this stochastic to ideal flow. Yeah. Yeah. So how to get the priority? Simple. You get the sum of row or the sum of column. It is pretty much it. So they are the same. Yeah. So they are phi, right? So and then you can get the relative power also. Based on that phi, you can get the relative power. Yeah. And the value is exact. Okay, the value is exact. Okay, because this is the actual stochastic matrix. When you put it into this is the IFN factor. Okay, when you put it into IFN and then you sum, oh, the sum is exact. Okay, as the first row here. Can you see? Interesting, yeah. Okay, interesting. So, okay, the sum of rows, but the sum of column is also exact the same. Okay, and not only that, okay, actually you can get if you look at the diagonal element here, okay, the diagonal element is already representing the priority. Okay, so and the proportion of this, if you calculate the power, they are exactly the same. Yeah, the diagonal element of the power of diagonal element, and this one is also exact the same. Okay, not only that, now you can start to see the F is actually symmetric. This is very interesting now. Yeah, theoretically, very interesting. Yeah? So the F is symmetric. Yeah. And the Sij, this one, is exactly the same. Okay. So, okay, or maybe this is for the factor. Let's calculate for the others. Okay, for the subject is the same, exactly the same. Okay, so you will get you see here, okay, the sum of row and the sum of column is exactly the same as the priority that you inputted. Okay, and of course the diagonal element also. Yeah, this one, if you calculate the power, is exactly the same as this power. Okay, so theoretically very interesting. Yeah? And of course the F is also symmetric. Okay. Yeah. No need to believe me, so you can calculate by yourself and change the numbers. Okay, it will always have the same result. Yeah, so this is very, very interesting because how can you get that? Okay, so this is the characteristic, yeah, of 1D stochastic. With this 1D stochastic meaning you have one D and then you repeat, right? So now when your capacity matrix or the stochastic matrix is actually one-dimensional, okay, repeating, okay, then your ideal flow matrix is always symmetric. Yeah, it's always symmetric. Okay. I will touch a little bit later. What's the meaning of this symmetry? Okay. So and then the relative R, meaning you have the S, this is the power, right? The power, okay, you get the minimum, okay, based on the diagonal element or based on the stochastic matrix or based on capacity matrix. Okay, this is based on the column or the row. This one is column, this is the row, right? So they are exact also. Okay. So actually the stochastic matrix, okay, the stochastic probability of each row can be computed based on relative R. Yeah, this one. So this R divided by the sum of R, you can get back the stochastic matrix. Yeah. And the diagonal, yeah, this is the diagonal, yeah, JJ, right? So that diagonal is actually the square of that relative R. Wow. Yeah, interesting, yeah. That diagonal is actually the square of this R value, yeah. That's the out value, the out ratio of each column. Yeah. So these are very interesting, at least mathematically, okay? You can get a few theoretical value that is actually very, very interesting. Okay. Next, you remember IFN come from Markov chain. Okay, what is Markov chain? So Markov chain is basically a powerful tool. So based on the stochastic matrix, you can get the equilibrium. Okay, so it's a very powerful tool for modeling and analyzing the system. Okay, where this is the actual assumption of Markov chain. Yeah, the past and the future state are statistically independent given the present state. Okay, that means this is called memoryless property, meaning all the previous values, okay, they forget. Only the last one, one last one, that is the one that they remember. That is the definition of Markov chain. Yeah. So this means the future state, it depends solely on its current state and the previous one, not the entire history. Yeah. So this is very useful for understanding and predicting behavior of many real world process. Okay. Now within the Markov chain, there is a special Markov chain which is called reversible Markov chain. Yeah. So the reversible Markov chain is a special type of Markov chain. Okay. What make it special? Because the probability of transitioning from one state to another is actually equal to the probability of transitioning back. Okay. That means the chain will can reverse in time. Okay, running forward and running backward is the same way. Okay, this property is called detailed balance. Yeah. So this is actually very powerful tool to understand the and modeling system also. Okay, what's the difference? Okay, now you have the past and the future are statistically independent given the present state. Okay, and this transition probability must satisfy what is called detailed balance equation, which is not in the original Markov chain. Okay, the detailed balance equation state that if the transition probability in state I, okay, want to go to state J, this is actually equal to the probability of being in state J going to state I. So can go back and forth. Okay, this is the formula of detailed balance. Yeah. So if you have the, can you remember this is in the IFN, this is basically the sum of row. Yeah. And this one in the IFN, this is the sum of column. Okay. What is this? This probability of I to J, what is that? That is actually the stochastic value. Yeah. So that is Sij. Yeah. How about this one? This is actually, oh, I think I reversed this one. This is should be J to I. I mistyped this. Yeah. So this one, so basically this is the formula of detailed balance. Okay. So let's compare this. Remember, IFN is actually irreducible Markov chain, right? So what's the difference between irreducible Markov chain and reversible Markov chain? So an irreducible Markov chain is where any state can be reached from any other state, right? So indefinite number of steps, yeah. So how about reversible Markov chain, yeah? So any reversible Markov chains are actually irreducible. Okay, so this is a subset, okay? But not all irreducible Markov chain are reversible, yeah? So you can draw a Venn diagram if you want. So that is my mouse, okay? So this is the irreducible, okay? So I, okay? And then the reversible is down here, yeah? R. Okay, the reversible Markov chain is a subset. Okay, so the key property here is actually what is called time reversibility, yeah, which is the detail balance a while ago. So in reversible Markov chain, the past and the future are statistically independent, okay, given the present state, even if we look the chain in reverse. Yeah, this is the property that does not hold in all irreducible. Okay. So next, in here, I just show the theorem that I make, okay, that any ideal flow network which is symmetric is actually reversible. So you can check the proof here by yourself. Yeah. So basically, this is the formula of detail balance a while ago. So now I'm connecting the dots. Can you see that? Okay. A while ago, you are computing the prioritization. Okay, but now I'm providing you with the theory that actually that prioritization, okay, representing 1D stochastic matrix, and if you put that into IFN, you will get symmetric IFN, which is now we can see that symmetric IFN is connecting to the reversible Markov chain. Can you see that? Okay, we are connecting the dot. So basically, you have very big theory that's supporting all this prioritization. That's the main point here. Okay. So instead of just arbitrarily creating any method to compute your prioritization, now you have the whole mathematics theory that helping you to support this theory. That's the main point. Is that clear? Okay. So usually we can get reversible Markov chain from symmetric and doubly stochastic. Yeah, when we say doubly stochastic means this one. Yeah, the sum in the row and the sum in the columns is actually all one. Yeah, this is called doubly stochastic. And if this is also symmetrics, yeah, you will always get symmetrics F. Okay. So this is an example. Okay. So if you have symmetric and doubly stochastic, you will get a symmetric F. So in that case, you will get the reversible Markov chain. Okay. But symmetric ideal flow does not always imply symmetric stochastic. Yeah. It's one way. Yeah. If you get symmetric stochastic, you get symmetric ideal flow. But if you have symmetric ideal flow, does not mean you can get symmetric stochastic. This is an example. Okay, this is actually symmetric ideal flow. Okay, but the stochastic are not symmetric. Can you see? This is 1/3 and this is 1/2. So this is not symmetric. Yeah. So asymmetrics can also produce symmetric ideal flow. Okay, and last time you also learned about ASP. Remember, right? So if you use ASP reciprocal matrix as capacity matrix, okay, thing like this, okay, then you will always get also symmetric ideal flow matrix. Yeah, so this is another interesting point. Yeah. So when I see this, it's blow my mind. Yeah. Oh, I can see the connection between all these dots. Yeah. So as a conclusion, okay, so IFN have a very strong theoretical foundation. Okay. Okay. So we can use IFN as MCDM tools. So to prioritize the subject and attributes based on multidimensional data. Yeah, tables. And this is actually unique, yeah, because you can suggest the weight, attribute, compare that to Brown-Gilson last time, compare to that MCDM last time, that you need to subjectively provide the weight. Can you see the difference? Okay. And then, of course, you can get the probability also for each subject. From here, you can get the normalized power ratio, right? So you can also analyze the power. Yeah. And not only that, so you connect that to the theory of Markov chains, with this reversible Markov chain, because the IFN is always symmetric. Based on that, you can also once you get the IFN, okay, you can do a lot of other analysis, yeah. So the one that we discussed last time. So you can calculate the cycle, you can calculate the signature, the pivot, and so on. Okay. So I hope this is useful enough for you. So one last challenge, okay. A while ago we said this is one way, not the other. So can you find a counter example that symmetric stochastic that does not produce symmetric ideal flow? Okay. So if you cannot find a counter example, then this is always. The theory is always based on just one counter example can collapse the whole theory. Yeah? That's the basic of science. Okay, with this, I would like to end the first slide. Any question about IFN prioritization? Did you get the idea? Yeah, I believe you get the idea and the computation. Yeah, computation is not so difficult at all. Yeah, it's just you normalize, you get the score, and then you get the probability of the attribute. Okay, and then from there you get the utility and get the probability. Okay, okay. So basically, what you have is data table. You get directly the prioritization. Okay. In other method, you need to judge. In here, you don't need to judge. It's automatic. Yeah. So in this case, you can automate this process. Okay. Any question? Anything to discuss? If not, I will continue with the next topic in our today's today is about decision. So how people make decision. You go to Moodle, get the slide on how people make decision. So, a lot of discussion here. So in this topic, okay, this is the start of decision analysis. I want to discuss a few things. Okay. First, I want to discuss what is decision. Okay, so let's define what is decision. And then next is when do you need decision analysis? Okay. After that, I will discuss classical decision analysis strategy. Okay, and I will end this with a discussion about destiny, yeah, versus decision. So this is more on philosophy. Okay, so let's start with discussion. So any one of you, can you tell me can you give example of important decision that you did recently? Okay, and did you use decision analysis for that decision? Can you tell me how did you decide and what strategy did you use? Oh, easy question. One. Everyone want to say anything? Or your recitation as well? Can you give example of important decision that you did recently? Decision to go for vacation. Yes. Okay. Did you use data decision analysis for that? Probably not. So, okay. Okay, this is not really important. Okay, so you just decide by instinct. Okay. Okay, in the past year, okay, how many important decisions that you make? Okay, there are some people saying that, you know, the higher quality of your decision, especially important decision, okay, that you make in your life, that represent how successful you are, right? Okay, so if you keep making tough decision, okay, then okay, you will level up in your life. Yeah. So nobody want to share? Okay. Okay, if you are shy, you can type in the meeting chat, no problem. Okay. So this is the important decision in your life, isn't it? Being born, of course, this is not your decision, but this is your parent decision, right? Okay. And these are a few important decisions in your life: to select the university or the school, to select the field of study, yeah, to stay or leaving your previous job, okay, okay, to select the house, to settle down, to select your spouse to be, okay, to select the thesis topic, yeah, this is also important. To select your career, okay, or the job, yeah, yes. Okay, so to select the investment, to select to have a child or not, okay. Sadly, one of the Nobel Prize winner, Daniel Kahneman, decided to take the euthanasia to die. Yeah, so that's also one of his decision. Anyway, so yes, you make a recent decision to set up to join. Okay, this class. Okay. I hope this class will be very useful for you. Okay, right. Okay, so this is what is the definition of decision. So definition of decision is conscious, okay, irrevocable allocation of resources with the purpose of achieving certain objective. Okay, so look at this important word here, conscious. That means you don't make decision unconsciously. Okay, so it's only based on intuition. Hey, that whatever you decide. Okay, so and that is actually not real decision. Okay, the same thing when we said irrevocable. Okay, that means break. Okay, So decision is actually similar to your deep thought. Yeah, before you put your bet on the gambling table, that is decision. So once you put your bet, okay, then it is no longer decision because you just waiting for the consequences. Is it clear or not? Okay. And when we say decision maker, okay, it is a person or a team, okay, with two things. Okay. One is responsibility, the other one is authority. You need to have power to decide, to allocate the resources. If you only have responsibility without the power, you are not decision maker. The same thing. Okay. If you have only authority but you have no responsibility, then you are not decision maker either. Okay. So, right. Thank you for all these comments. Yeah. So, decision to which task to complete first, that is not decision, that is prioritization. Yeah. The one that we discussed in decision analysis here, this is the definition of decision. Okay. Can you see the difference now between the prioritization and the decision here? Okay. So, next question. This is probably important. Who are the people responsible for your life situation right now? And who responsible for your decision in your life? Your wife? Yourself? Okay. Is it God responsible for you? Right, majority said myself. Okay. How about your parent? Your government, probably? Right. So, this question we will touch later, okay? When we talk about destiny, okay? So, here is the diagrams, okay, on decision analysis, okay? So, the role of decision analysis is to not to provide you with the answer, which one should I decide? No, okay? Decision analysis is like a mirror, okay, that help you, okay, with an insight about the best course of action, okay, given the opportunity and your own preference. That means it will show who you are. Okay, it's a mirror to show who you are, meaning your own preference, your own opportunity. Okay, it will not give you the answer. Okay, so this flow chart, okay, look at this. If your decision is obvious, yes, then you make decision based on instinct. So you don't need decision analysis. Okay. If your decision is not obvious, the next question is it covered by the SOP, the policy? Okay. If it's already standardized, you just follow that standard and then make decision. Okay. You don't need decision analysis. Is it clear? Okay. Next, is it not covered by the policy? Okay, then you ask, is it recurring or non-recurring? If it is recurring, then you ask whether you have major consequences or not. Okay. If not, no major consequences, just examine the previous decision and just make decision. Okay. Now, if it is non-recurring, so then you ask, is there many choices or not? If you said no choice or just go and no go, okay, then you ask again, is there major consequences or not? Okay, again, back to make decision if there is no major consequences. But, okay, now if you have many choices, okay, and you have major consequences, then that is the time that you will use decision analysis. Is it clear? So you don't use decision analysis for just small things. Okay. You don't use Canon to kill mosquito. Okay? Otherwise, you will destroy your own house, right? Okay. Okay, so now let's discuss, okay, how you will reconcile with your leader who demand answer instead of insight. I'm not sure how to answer that question. Okay, decision analysis. Okay, after we discuss later, yeah, and in under uncertainty risk and so on, then you start to see the role of decision analysis in clearer way. Okay, this will give you the insight. Okay, now let's discuss first, okay, the classical decision analysis. Yeah, over time you will see, okay, how people create, okay, how can we make a decision? What kind of strategy we should do? Okay, based on the theory that they develop. Okay, so not all of that are correct, but right now, because that's why we call it classical. Okay, and the majority of these, I will just discuss 4 of them. Okay, many, but I'll just discuss 4 of them. But at least by knowing this, okay, you start to understand the merit of modern decision analysis. Okay, okay, let's start with the simplest one. Okay, which is called lexicographic strategy. Okay, and then we will discuss EBA, and elimination by aspect, and then the improvement of that is semi-lexicographic and satisficing. Okay, so the first one, lexicographic strategy. How you decide? The strategy is simple. Focus only on the most important attribute. After that, you select alternative that is the best on that attribute alone. Okay. Now, in case you have tie, then you select the second most important attribute. Okay. And then you select the alternative that is the best on that attribute. Okay. Is it clear? I will give you examples so that it's clear. Okay. Say you want to buy a computer. Okay. So the most important attribute, say you say price. Okay. Then what you will do, you will just find the cheapest among the available computer brand. Okay. So in this case, only one attribute that you fix. Okay. Even though probably you have other features, yeah, other attributes, for example, CPU speed, reliability, memory, and other features. So you completely ignore other features. Say, if the price are high, then you start to consider other features, for example, memory and speed. Yeah. Is it clear or not? Lexicographic strategy. Yeah. Focus only on the most important, and then you select based on that attribute alone. So it's one criteria. Okay. So the second strategy is called elimination by aspect. Okay, this proposed in 1972 by Amos Tversky. So how to do? Okay, the different with earlier. Okay, you can start to see. Yeah. So you identify again the most important attribute. Okay. Okay. The difference is now you set up the cut-off value on that attribute. Okay. So EBA, elimination by aspect, you remove all the alternative that fail to meet the cutoff value. And then you repeat the process to the second most important attribute and so on until only one alternative left. Okay, so let me give you an example. So say you want to buy a used car. So what you will do, you will find in the internet or the newspaper and magazine, right? So say based on what information that you have, you get 100 alternatives. Wow, a lot. So then what you will do, you will use EBA, yeah, elimination by aspect. Okay, so then what you will do? Oh, and you eliminate all the car. This is the first attribute, engine size. Yeah, all the car that below 1600 cc. Yeah, so in that case, you have from 100 you get only 70 alternative remain. Then you go to the second attribute. Yeah, so based on the price. Okay, say if beyond certain value or below certain value, you don't want that. So you get the second attribute done. So you get only 35 alternative remain. Yeah. Next, you go to the next attribute, which is reliability. Huh? So say you want to eliminate all non-Japanese and German car. Okay. So you get only 17 alternative remain. And then you base on the age. Okay. And then you remove all the car older than 4 years old. Okay. So you have only 5 cars remain. And then you base on color. Okay. So you remove the non-black car. So only 1 car remain. So in that case, say for example, your decision is this one. Yeah. So what's the problem with EBA? Yeah? Well, the good thing is it's useful if you have many alternative, say in hiring process nowadays. Yeah. So people are starting to use AI because say the number of applicants is so many. What they do is they probably use this, yeah, EBA. So it's good to remove many alternatives. But actually it is very poor decision, yeah, because the sequence of the attribute matters. If you go to the first different attribute, yeah, then you will have different result. Okay, so it's failed to ensure that the alternative retained are actually superior by those that eliminated. So this is the problem, okay, in all this classical method, yeah, in the decision analysis. What is that? The problem is non-compensatory strategy. Okay, so poor performance in one attribute is not compensated by the good performance in other attribute. Compare that to when we discussed IFN prioritization a while ago. They are compensatory. If one attribute is low, the other one is bigger. Okay, there is some weight, so it's compensatory. In here, is not. Can you see the difference? Okay, so next we go to the third strategy that we want to discuss. So we call it semi-lexicographic strategy. What is that? Okay, the same. So we focus, similar to lexicographic strategy, we focus on the most important attributes. Okay, and then if the performance alternative is similar, okay, then actually the difference is not that much. We consider them as tie. And then we move to the next most important attribute. Okay, so this is an improvement. This is an improvement compared to the lexicographic, and then this is an improvement compared to EBA, elimination by aspect. But there is still some problem. Okay, why? Because it actually leads to contradiction. I will show you in an example. Okay, say your strategy saying this way, yeah, this is the based on semi-lexicographic. So you set a threshold, yeah. So you have 2 attributes with this price and quality. Okay, of course, if the price is important for you in rank 1, and then quality is rank 2. Okay, so now you set up this strategy. If the price difference is less than 0.5, okay, then choose higher quality product. Okay, so of course, if the price difference is larger than 0.5, what you will choose based on price. Yeah, so ignore the quality. Yeah, that exactly semi-lexicographic. Yeah, focus on the most important attribute, unless they are tied, right? So let's check one by one. Okay, what happens if you check A and B? The difference on price is less than 0.5. So if less than 0.5, what you will do? You will choose the higher quality. So in this case, medium, right? So you will choose B. So I put here, can you see this? So you choose B, okay, B is larger than A based on comparing A and B. So let's compare now B and C, okay? So the difference is less than 0.5 also, right? So in that case, because if the price difference is less than 0.5, what you will choose? Higher quality product. So you will choose the medium, between medium and high, you will choose high. So C is higher than B, right? Now let's compare, okay, C and D. Oh, this is also less than 0.5. Okay, this is also less, this is just 0.2, right? So this is less than 0.5. So in that case, you will select medium and high. So which one? You will select C. Yeah? So C is higher than D. Correct. So let's compare B and D. Yeah? So this one, B and D. Oh, this one, the difference is also less than 0.5. But they are the same, yeah, medium and medium. So in this case, you will say B is equal to D. Okay. So with this, if you just based on this comparison, okay, what is the conclusion? The conclusion is A is less than B, right? B is equal to D, and then both of them is less than C. So C is supposed to be the winner in here, correct? So you will select C. But let's compare C and A. This one. The difference is more than 0.5. So if the difference is more than 0.5, what you will choose? Based on price alone, you don't care about quality, right? So in this case, the price is larger than 0.5. So you will decide based on price. So if you choose based on price, what is the conclusion? A is larger than C. Hey, in here, A is the lowest. In here, A is the highest compared to C. So this is actually a contradiction, right? So you're telling that, look, semi-lexicographic strategy can lead to contradiction. Okay, if you make decision making based on this strategy, you can have contradiction here. This is what we don't want. Okay, so the fourth one, okay, this is based on a proposal of Herbert Simon. Herbert Simon is a Nobel Prize winner, so you can check this in Google. Yeah? And you can also check the meaning of statistics. Yeah? This is so here it is. Yeah? He said that, look, usually we make decision sequential. Okay, why? Because the alternative probably not available all at one time. Okay, but it will become available sequentially over time. So it's a dynamic here. Okay, a while ago it's just 1 to 3 is just one today, okay, or present time. But statistics talking about dynamic. Okay, so it will become available sequentially. So, for example, over 1 week or 1 month, okay, over 1 year, okay, so now the assumption, okay, is this: each decision maker has some kind of aspiration level. Okay, what is aspiration level? Something that characterizes whether this alternative is acceptable or not. Okay, so you have, if you choose based on your aspiration level. So then this is the what is called satisficing strategy. Okay, so you will wait and continue to wait to search until you receive satisfactory offer that exceed your aspiration level. For example, so you want to find job, okay? Then you just newly graduate, you don't want to, find job yet because all this job is not satisfying below your aspiration level. Okay, so you delay. Okay, you refuse excellent job, but over time, because you keep get rejection, okay, in your application, then your aspiration level go down. Okay, and eventually, what you will do is you will accept, okay, actually lower quality job than previously. The same thing, yeah? If you want to find a spouse to be, okay, at early stage, you may delay, you refuse excellent candidate. Yeah? But after some times, what happens is your aspiration level may go down because you keep getting rejection, and eventually you will not get the best. Okay, so again, all these four classical strategy in decision making is actually non-compensatory. Yeah, so there is no trade-off among these criteria. Yeah, for example, in the job, okay, how much holiday you will give up for higher salary? So between salary and number of holiday, there should be some kind of trade-off, right? And then also the final choice depends on the order of the alternatives show themselves. Yes. In God's time. Right. So my question, in selecting your spouse, okay, whether in the past or to be, okay, what strategy did you use? Okay. Okay, and how did you select the candidate? What are the attributes? What are your aspiration level? Anyone want to say something? Huh? Spouse is about cost and effort. Oh, come on. In selecting your spouse to be your girlfriend, your boyfriend, what are the attributes that you use? You don't have option because you are always online. Okay. Okay. So yes. So this is the partial list that I put. Okay. I don't know what strategy to use. Okay. So usually we use compatibility, yeah, maybe some appearance, okay, some character, yeah, some spirituality and family background. Okay. These are something that with question mark, yeah. Okay. So how about this one? In selecting your career or work, what strategy will you use on, and then what are the, how did you select the alternative? What are the attributes that you use to find job, and what are your aspiration level? Anyone want to discuss? Nature of work, salary, workplace, yeah. Fulfillment, okay, the pay, personal growth, correct, okay. Okay, so the growth opportunity is important for you. Salary is important, okay. Work environment, okay. So is it should be within your field of study. Okay, so good. So yeah, these are a few attributes that are listed by previous year students. Yeah? So salary, benefit, training availability. Yeah, maybe the location. Okay, online job probably is one of the trend nowadays. Yeah, and the workload balance. Yeah. Okay, alignment with long-term goals. Okay, that's good. Right. Okay, so the last part that I want to discuss is about destiny. Okay, yeah, culture. So the actual destiny actually never exists. Yeah? Destiny is actually only our own perception and concept toward life. So then we can have four views. Okay, view one is our destiny is actual consequences of mainly other people's decision around us. Okay. Second view is our destiny is just a consequence of mainly our own decision. Okay. The third view is our destiny is actual consequence not only our own decision but also decision of other people and the nature surround us during our lifetime. So the time matter here. Okay. And the fourth view is also include our past, yeah, decision of our ancestor and the people surround them facing the nature at that time, also still facing us weekly. Yeah. So with that, we can put four shareholder of our destiny. Yeah. What happened in our life? Okay. So who make this happen? Okay. Is actually our own decision or decision of the people surround us recently, or actually the decision of our ancestor and people surround them in the past, or decision of the nature. Yeah? Nature also influenced us, you know? Yeah? Recently and in the past. Yeah. Based on this, we can put four type of people. Yeah. So based on how we perceive decision, yeah, we can behave like a victim. Yeah, that all decisions are made based on the influence of others around us. Okay, or we take responsibility. You are the one who responsible for the consequences of your own decision. Right? Okay. You can Google. Okay, in Revoledu there is article, okay, how to be a lucky person. So I wrote that 20 years ago. Okay. The third type of person is actually aware, okay, that our decision is not only based on our life, okay, but also the life of others surround us. Okay, the people in the government also influence you, right? With their decision, even though it is not your decision. Okay, but not only that. Okay, if you are wise enough, then you also know that our decision will also influence the life of others in the future, because our ancestor decision, okay, influence us. Okay, say I give you example. Okay, so my ancestor came from China. Okay, because at that time there were famine and war, and they moved to Indonesia. Okay, their decision at that time probably optimal, but it will affect me right now. Okay, where will I go and so on? Similarly, so we are telling that look, not only okay, we are responsible for our own decision. Okay? We are actually also responsible not just for us, but also for the our our children, our great-grandchildren as well. So that means whatever you decide today, okay, is not just for you, but also for the future generation that probably you never see. Okay. So our next topic in decision analysis, okay, we'll discuss about this topic in the next few weeks. Yeah. So today we'll discuss this part, decision under certainty and uncertainty, and next week we will discuss about this one. Yeah. Maybe the following weeks we can go to game theory and group decision. Okay. So about this classical decision and how people make decision, is there any question? Anything to discuss? Is there anything to discuss about this? So if not, you can go to decision under uncertainty. And you can go to the slide decision under uncertainty. So this is part of decision analysis. Okay. So again, these are the topic in decision analysis. So this is our topic today. Yeah, decision under uncertainty and certainty. Yeah. So I will discuss first about component of decision and then type of decision maker, and then we will go to the technical, yeah, which is how to compute. Okay. This is based on the criterion that we use. And then I hope you can compare the one that we discussed earlier, the classical strategy, which is non-compensatory, and then the IFN a while ago, which is practically multi criteria decision making, with this one, yeah, decision under uncertainty. Okay, so first, what do you think about what is good decision and what is bad decision? Can you explain how can you have good decision outcomes from how can you get a good outcome from bad decision? Anyone have thing to discuss? What is good decision for you? So yes, good decision, yeah, good decision have good result, right? Okay. Okay, you said lucky if good outcome from bad. Okay, so there is some kind of lucks that you think it may happen. Okay, good decision is when the weight concern of stakeholder get acknowledged. Wow. But decision have negative long-term effects. So okay, you talk about the outcomes, right? Okay, the result of that decision. Okay, so this is what happened. Yeah, this is what is called decision under certainty. Okay, so if you say decision under certainty, okay, so good decision will have good outcomes and bad decision will have bad outcomes, isn't it? Right? So, but in reality, okay, good decision can have either good or bad outcomes. And then bad decision can also have good and bad outcomes. So we are not sure. There are certain kind of luck that you have. So this luck things, you put it in the circle here. Okay, so this is the one that make it uncertain. So there is uncertainty in the future. Okay, so in that case, you are not sure. So knowing that this is uncertain, what to do? Okay, how can we make decision to ensure, okay, at least have certain things that we can make? Okay, so in that case, let's discuss the component of decision first. Okay, so there are three components of decision in this context. Okay, so we have what is called alternative. Okay, and then we have opponent, okay, either intelligent being or nature, and then we have the outcomes. Okay, now these three components, you can put them together into single payoff matrix. Okay, let's discuss what is the alternative means. Okay, the alternative is the choice, okay, that you as decision maker can make. So this is basically a feasible allocation of resources which are available now or become available to you later. Okay, so if you want to generate alternative, that's of course you can brainstorm. Okay, that represent the creativity. Okay, or certain knowledge in your problem domain. Okay, so my message is simple. You always have choice. Yeah, you always have alternative. Why? Because doing nothing is already one of the option. Okay, so if you have one proposal, okay, compared to okay, the politically correct jargon is not do nothing, yeah, do minimum, right? That's practically the same as do nothing. Okay, so when you do nothing, okay, that's the current condition. You don't do any decision. Okay, that's actually a decision by itself, right? It is an alternative. Okay, so you can always make that new alternative. Okay, now the second component is the state of nature, because you are not sure. Okay, there is uncertainty in the future event. Okay, then you define the state of nature. Okay, whether it is lucky or unlucky, whether the demand is good, high demand or low demand. Okay, in the weather probably rain or not rain for your rice, and the price is actually up or down. Okay, that these are quantitative measure that you can put it into qualitative. Okay, so you design the state of nature to be mutually exclusive event. Okay, so yes, you can also estimate the probability distribution of each state of nature. But at this point, you don't need to. Okay, in decision under uncertainty, you don't need to compute the probability distribution. That is in the decision under risk. Okay, so then you have the third component, which is outcome. Okay, so either you determine the outcome or you estimate the outcome. So outcome is basically quantitative in nature, either gain or cost for its alternative and for its state of nature. Okay, so with this, you have what is called payoff. What is payoff? Payoff is a consequence. Numbers, a measure, okay, how you will put the consequence of your decision. Okay, this is an ordinal number, okay, not necessarily in terms of money. Yeah, you can put in terms of money or you can put it in terms of any value with this ordinal value. Okay, comparison is the most important here. It's not the actual value, ordinal value. So with this, each combination of decision alternative and each state of nature will have the payoff values. So hence, you have the payoff matrix. This is the example of payoff matrix. Okay, you see here, you have the alternative. So for example, the alternative is bold action or conservative action, and the state of nature. Okay, favorable or unfavorable. Is this clear or not? Can you distinguish this? Compare this with earlier in the MCDM. Okay, in CDM you have also the alternative, but in here is not state of nature. What you have is the attribute. Yeah, in here we don't care about the attribute. We care about the state of nature or the intelligent being. Move of the other. What is the move of other intelligent being? Can you see the difference? Yeah. Okay. So what is this number? Okay, these are the payoff. Yeah. So you can either use gain table or you can use loss table. Okay. So if you use gain table, so you will see here. So if I take bold action and the condition is favorable, I will get 150. Okay. If I take bold action and the condition is unfavorable to me, then I will lose 50. Negative mean loss. Yeah. In gain table, negative mean loss. Okay. If I take conservative action, so basically I do nothing. Okay. I will still get 20 if the condition is favorable, and then the same. Yeah. I will get 20 if the condition is unfavorable to me. Okay. Now you can put this gain table into loss table simply by putting negative value. Yeah. Okay. Of course, the meaning is the same. Yeah. So in here, if you put 50, that is loss. That means negative 50 in the gain table. Is it clear? Okay. Next, I want to discuss 4 types of decision maker. So, what type of decision maker are you? Okay. So, are you aggressive, conservative, opportunistic? Yes. And then average. Okay. What is this type of decision maker? Yeah. If you have aggressive strategy or optimistic, okay, so you will seek option that hold the promise of maximizing the potential return. So you will always ask, what is the best that could happen in its decision? Okay, so you are risk taker, yeah, risk seeking or speculator. So you will increase the exposure to risk in the hope that you will gain higher return. So high risk, high return. This is a aggressive strategy. Okay, so the jargon in decision under uncertainty is maximax or minimin. Yeah, maximax the gain or minimin the cost. Okay. The second type, okay, is conservative, yeah, or pessimistic. Okay, majority of people are in this category. Okay, so what you do, you maximize the smallest potential return. You see here, maximin. Yeah, maximize the potential return, the smallest potential return. So then you can ask like this: what is the worst thing that may result from my decision? Okay, being pessimistic is not bad. Okay, being conservative is not bad. In fact, majority of people are risk averse. Okay, but they will forego the potential return in order to reduce the exposure to risk. So the strategy is maximin gain or minimax loss. Okay, so I will show you what is the meaning of maximin minimax later. Okay. So the third type of decision maker is based on opportunistic. Okay. They want to minimize the regret. How often do you regret in your decision? Okay, then you can use this. Okay, so opportunity loss represent the regret that people feel after making non-optimal decision. So you will say, I should have done that before. Okay, so using this technique, now you can quantify your regret. How I quantify my regret? Regret is simple. The difference between the best decision of that particular event and the payoff of that decision. Okay, because regret represent negative payoff, it is represent the cost. So in that case, you want to minimize. So you minimize the largest opportunity loss, which means you minimax regret. Okay. The fourth one is based on average. Okay, so you just since everything is actually unpredictable, so probably the best way is to assume, equally likely to occur. Yeah, this is the same as maximum entropy. So, and you simply average the payoff, and then you get the average, the best on the average payoff. Okay, so the best depends on whether it is gain or cost. Okay, so if it is gain, you want to maximize. Yeah? If it is cost, you want to minimize. Simple. Okay, so now this is the characteristic of decision under uncertainty. Okay, you don't know the probability. Okay, and the decision based on criterion. Yeah, we will discuss the criterion later. Okay, and then there's a range between optimistic to pessimistic or somewhere in between. You can also use gain payoff or cost payoff matrix. Okay, so what are the criterion? Okay, these are the criterion that has been proposed. Okay, so you can use maximin rule or minimax, or you can use maximax rule or minimin. Okay, so this is pessimistic or conservative. This is optimistic. Or you can use Laplace equal probability rule. Okay, this is based on average. Or you can use minimax regret rule based on the proposal of Savage. Or you can have these two together. Okay, in one rule called Hurwitz rule. Okay, so in your Excel, can you type this first? So that you can, in your Excel, can you type this? Okay, this can be gain, can be cost. Okay, so but put this number so that we can do it together. Can you? Just type these 9 numbers and the alternative and state of nature. Yeah, clearly this is like a good, medium, and low, probably the state of nature. And we have the 3 project or the task. Done? Did you type? Okay. So once you're done, so we can start with the first criterion, which is based on maximin rule, or minimax, maximin, the first word here is max, that means based on the gain, The first word here is min, that means based on the cost, look at the first word, Okay, so you will use this rule if you are pessimistic and you want to play safe. Hey, this is not bad. Why? Because it guarantee you will get the minimum payoff, certain minimum payoff. But you will completely bind on high potential payoff if you use this. Okay, I will show you. Okay, so what is Maximin rule? So you have gain table, right? The one that earlier like this. Okay, so this is I, okay, and this is J. Okay, so I is the row, J is the column, right? Oh no, I used J and K, sorry. So J and K. So J is the row, yeah, row, and then K is the column. Is that okay? Column. So what you will do if you use this Maximin rule is simply you, from the table, okay, you minimize over K, over the column. After that, okay, the result of this minimization, you take the maximum over the row. Okay. Now, if you have cost table, okay, the same J and K, first you maximize and then you minimize. Yeah, the maximum for the column and then you minimize over the row. And then you take the argument of that minimum or the argument of that maximum. Okay, I will show you in the example. Okay, so okay, there is a note here that in general, maximum gain is not the same as minimum cost. Yeah? Even if you use the gain equal to minimum cost. Yeah. Later in game theory, you will learn about maximum equal to minimax. Yeah, when you get the equilibrium. Okay, so let's go back to our practice here. Yeah. So you have this table that I asked you to type. Okay. Say this is gain. Okay. So if you use gain, then that means you need to maximum gain. What you will do, you do the second part first, which is the minimum. Okay. So 5, 7, and 9. What is the minimum?
5, sir.
5. Okay. And here, so you get 5 here. Okay. Now, 10, 5, and 0. What's the minimum? 0. Yeah. 23 and minus 15. What is the minimum? Minus 15. Yeah. Easy, yeah? So you minimize first. And then you maximize. So 5, 0, and minus 15. Which one is the maximum? 5. Okay. And then you get the argument, which is A. Easy or not? You can do it without Excel. You can just look at the numbers. You can get the result already. Right. Okay, so in Excel, you just minimize and then max. So the maximum is over this value. Okay. So what is this result? 5. What is the meaning of 5? Look, this 5 is important. Why? Because you are guaranteed to get, if you use this maximum gain, you are guaranteed to get 5. Okay, you will not get minus 15, you will not get 3, you will not get 0 if you choose A. Okay, so you are guaranteed to get at least this value. Okay, but you cannot get 20, you cannot get 10. Is it clear? Any question? Okay, so what happens if this is not gain, but this is a loss? So then I will make it negative, yeah? Yeah, okay. So I make it negative. So that Why I'm getting negative? So that I will compare, okay, whether the decision is still the same or not, right? So then the same. If you are using cost, what you will do, minimax, yeah, not maximin, yeah, because min is the cost, right? So first you max and then you min, yeah. So in here, -5, -7, -9. What is the maximum? -5, yeah. -10, -5, 0. Which one is the maximum? 0, right? And then -20, -3, and 15. Which one is the maximum? 15. Okay. And then among these, you get the minimum. Is it clear or not? So the minimum is -5. That means the loss, okay, at most is -5. Clear? Easy, yeah? Yeah. So in fact, you don't need Excel, yeah? Just look at it, just maximum, and then you get the minimum. Okay. Once you get this, of course, you get the arc. The arc is the argument. That's mean the decision. So you can still get the decision, okay, based on this. Right. So, but now this is a cost. Okay. The larger is the larger cost. Okay. Even though the value is positive, that means higher number mean higher cost. So can we use minimax? So what you will do is max between 10,100 and 100. Which one is the maximum?
10,100.
Yes, 10,100. Okay. And then the other one, the second one, 10,000 and 10,000 is the same, right? So you get 10,000. Okay, so this is the max. Okay. And then what you will do, you will minimize. Okay. So the result is P. Right. So you will choose P. If you use minimax, you will choose P. Oh, but this is against intuition, right? Because you see, you lost only 100 here against 10,100. Okay, so actually, A is actually better intuitively than B. Okay, but because you use minimax, okay, this is just to show. Okay, this example is to show that minimax criterion is blind or better potential payoff. If you just use the mechanics without thinking, okay, you will choose B. Okay? Even though logically you're supposed to choose A, right? Okay, if cost is complicated for you, think in terms of gain. So in gain, what you will do, you will get maximin, right? So look at this. What you will choose, minimum of this, 1,019,000. Which one is the minimum? 19. 20 and 20, still 20, right? Yeah, you minimize first, right? After that, you get maximum. Between 19 and 20, you choose 20. So you will choose B. Again, this is very funny. Why you choose B when you potentially can, if you choose A, potentially you can get 1 million. And if the condition is unfavorable for you, you will get 19, so -1. But you still choose B because you are using maximum gain. So this is again counterintuitive, yeah. So, right. So, okay, maximin, minima is not that good. Okay. But at least this give me a foundation. Okay. This give us some foundation about how we will proceed with this. Okay. So then let's go to the second criterion, which is maximax gain or mini-min loss. Okay. You will use this if you are very optimistic and play very high risk. Okay. You are guaranteed to get a certain maximum payoff. but you are completely blind on the relative magnitude of the payoff. Okay, so what you will do, you will select max if it is gain, and then if it is cost, you will choose mean. This is very easy to do. Okay, because what you will do is just get the maximum in the whole table or the minimum in the whole table. Okay, so note that maximax gain is always equal to the minimum cost if you put cost equal to negative gain. Okay, so again, we use the same numbers. What we will do, you get the max. Yeah? For example, if you use max, what is the value? 20, right? So you will choose C. Okay, look at the same number, I can create different decision. Okay, depending on the criterion that you choose. Okay, so I will choose 20 here. Okay, if you put this as negative, okay, so loss table, okay, then again you will choose the same value, yeah, 20 also. Okay, so based on very optimistic, okay, way to decide, okay. Okay, in the next example, you will see how this actually also counterintuitive. Okay, so show in here what is the max. This is gain table, so you use max. What is the max here? 20 and 21. Oh, the max is 21, isn't it? Not 20, yeah. So you will choose alternative A, right? But this is very dangerous. You see, if the condition is unfavorable to you, okay, compared to this is only one the difference. But if you see if the condition is unfavorable to you, you will have to pay 1 million. To gain 1, you lose 1 million. This is counterintuitive, right? So why? Because max rule does not recognize, okay, the relative magnitude of the payoff. Okay, so that's why you still choose A in here. Okay, so don't use maximax, minimax, and maximate. Okay, so the first two criterion are not good. Okay, so what is good then? Use this one. Yeah, you can use this one. Yeah, you can use one alternative to solve this is to use the Laplace equal probability. Yeah, because you don't know, okay, then you assume uniform. So you assume equal. Yeah. So this is called the principle of insufficient reason. Yeah. It states that if you do not have enough information, then the probability that the probability will be different, then treat them equally. Yeah. So without knowing, since elementary school, you already use this. Okay. When you have a pizza and then you have 4 persons, what you will do? You will divide by 4, right? Every time you do division, is actually what you do is you assume uniform distribution. Okay, you are actually already applying the principle of insufficient reason. Okay, so decision is based on average in this case. So what you will do is you take the average on each row. Okay, say if this is cost table, say assume cost table. So you take the average of the row here. Okay, and then because this is cost, so what you will do is you minimize. Okay, if it is gain, you maximize. Clear or not? Easy, yeah? Okay, so Laplace equal probability, you just assume equal. So in that case, you just take the average in each row. Okay, so but be careful about the state of nature. Because you assume equal probability, don't split the state of nature. It must be mutually exclusive and exhaustive. Yeah. So if you split and relabel the state of nature into more categories, then they are no longer equal probability. Okay, so this is the problem. If you are cheating in the number of state of nature, okay, then you will have trouble in deciding the actual probability here. Okay, the next criterion that you can use is also very interesting. It can overcome those problems in minimax and maximin is called minimax regret rule. Yeah. Yes, we can still use minimax, but we use a comparison. Yeah, comparison between the maximum with the actual value. So this is what is the definition of regret. Okay. Now, if you have gain table, okay, so you take the maximum of each column, okay, and then you minus with the gain table. If you have the cost table, you take the minimum of each column and then you minus with the actual cost. Okay, either this one or that one, so you will get the regret. Yeah, regret table is also the same size, yeah, of the gain or the cost matrix. Okay, regret is sometimes called opportunity loss, yeah, which is the absolute difference between the payoff and the maximum payoff. Okay, so because regret is actually loss, so you minimax. Okay, so this suffix is the name of person. Yeah, in fact, this is pretty good. Yeah, so it will give you better logical conclusion than simple minimax cost. So use this. Yeah, so use this. So let's use the same table. Okay, at this time let's assume gain table. Okay, so what you will do? Okay, so this is the number that you have in you already typed like a while ago. So this is the payoff value gain. Okay, what you will get is the maximum payoff in each column. So 5, 10, and 20. The maximum is 20. So you put in here that column all 20. 7, 5, and 3. Which one is the highest? 7. So there, you put all 7 here. Okay. Here, 9, 0, and 15. Which one is the highest? 9. So you put all 9 here. So this is called the maximum payoff. Okay. So you have the payoff, the gain payoff, and you have the maximum payoff. So next step is to get the absolute difference. Yeah, which is the regret. So look at this. This is the payoff, and this is the maximum payoff. What you will do, you take them absolute difference. Yeah. So 20 minus 5, you get 15. Yeah. In the last part here, 9 and minus negative 15. So you get 24. Yeah. Again, one more in here. Yeah. So 20 minus 20. So you get 0. Is that clear or not to get the regret? Okay. Once you have the regret, what you will do minimax regret. Yeah. So here is the value. You get the regret this way. So then you minimax. So max first. Okay. So you max from here. It's 15. And this one is 10. This one is 24. And then you get the minimum. Yeah. So you get the minimum. So the argument of this is B. So the decision is B. Clear or not? Is it too fast? You want to practice this? Minimax regrets. or you practice this one. This is only 4 values. Okay, a while ago, when we use minimax, okay, this failed, right? This failed us intuitively. So can you calculate this using regret? So be careful, this is cost. Okay, so what you will do to get regret, okay, if you want to get regret, you base it on this formula a while ago, this one, yeah, C, okay, minus the minimum, yeah, of C, okay, so can you try? How is it? Is it difficult or clear? So this is cost, so what you will do? Okay, so if this is cost, what you will do, okay, so this is the actual cost, so you get the minimum cost, yeah. So for each column, you get the minimum, so you put that value, right? This is the minimum is 100, so you get that value, okay. So regret is just the difference, yeah. So this is 10,100 and then 10,000, you get 100 here, right? So you just minus, okay, so you get the regret, okay. So once you get the regret, what you will do, you minimax, yeah. So even though it's not depends on the original table, yeah. It depends on the regret. So in that case, you minimax, okay. So minimax, that means you do the max first and then you do the minimum, yeah. So the max is 100, the max is 9,000. So the minimum is this one. So in that case, you will choose alternative A, yeah. So minimax regret actually give better logical conclusion than the simple minimax. Okay, so the last criterion that I want to discuss with you before we end is Hurwitz. Yeah, this is the so I give you assignment there in Moodle, so please do it so that you can practice more. Okay, so what is the Hurwitz? Hurwitz is based on minimax and maximin and maximax and minimin. Okay, how can it be? Okay, he generalized the first 2 criteria. Okay, so it will range between pessimistic and optimistic. And if you look at this, okay, this is basically learning, similar to learning model last time, we discussed, remember? You have alpha and you have 1 minus alpha multiplied by something. So let's do this. Okay, let's put alpha is 0, what will happen? If alpha 0, so this one is 0, right? So you have 1 minus 0 is 1. So basically you have arc max mean. What you get? Maximin. Aha. So if alpha is 0, you are pessimistic. Okay. So what happens if alpha is 1? If alpha is 1, so 1 minus 1 is 0, right? So this one is you are not using. So this is 1, so you get maximax. Oh, you get optimistic. Yeah. So that means the meaning of alpha is the degree of pessimistic to optimistic. So you have a single parameter here. Yeah. Now depending on whether you are using gain table or you are using cost table, then this is the formula. This is gain table formula. This is cost table formula. Okay, so let's take example so that you can get a clearer value. So let's say this is gain table. Okay, so in that case, I will use this formula here up. Okay, so copy this formula. So that this is the formula I copy. Yeah. Okay. So this is based on loss table. Okay. So if you use gain table, this is based on loss table. Okay. This is based on gain table. Okay. So this is the formula I'm using. Okay. So what I will do is, okay, first I calculate the minimum and the maximum. Okay. After that, I will calculate that criterion. The criterion is based on that formula a while ago. Yeah, it is based on alpha. Okay, and then of course you maximize because this is gain, so you maximize. Okay, maximize here. If this is cost, of course you will use this. Yeah, you will use this formula. Yeah, and this is negative. So anyway, you will get the same result. Yeah. Okay, and from there you can also get the data table. Okay, and then you can plot the sensitivity analysis of Hurwitz. Yeah, something like this. Okay, so with this, hey, there are three decisions, right? Supposed to be A, B, C, right? Okay, based on this, it's supposed to be A, B, C, but you see here, based on sensitivity analysis, okay, whatever value of whether you are pessimistic to optimistic, you will not have decision B, yeah, only A and C here, yeah, based on sensitivity analysis, yeah. So, what happened if your value is below certain value here, so you will choose A, yeah. If the value is above this threshold, you will choose C, yeah. So remember, higher value represent optimistic. So if you are optimistic, right? If you are optimistic here, so you will choose C. Yeah? If you are pessimistic, you will choose A. You will never choose B anyway. Yeah. So in this case, Hurwitz only generalize max and maximin gain or minimin and minimax cost. Yeah. But it doesn't include Laplace equality and minimax regret rule. Yeah. With that, you practically have only three. Yeah. So either you use Hurwitz or you use Laplace or you use Savage minimax regret rule. Is that okay? So in conclusion, this is what you do. Okay. So based on decision under uncertainty, you select among the number of alternatives, yeah, based on the outcomes, okay, based on the state of nature, okay, and then you know that the probability of the state of nature is unknown, okay. So that's why this is called uncertainty, yeah. So this is very important properties, yeah. So and then you will see when you apply different criteria or different criterion, you will have different decision. Okay, all rule have some weakness. Okay, so maybe better approach is to use under risk later or under utility later. Yeah, or in the game theory. So, but we will build on top of the next. So you need to learn this first before the others. Yeah. So, in here, I want you to play, draw here a line connecting the dot. Can you? In the screen. This is the test. So if you are optimistic, which one you will choose? Optimistic, you choose maximax.
Maximum.
Yeah, or mini-min. Yeah. When we said conservative, they are actually the same as pessimistic. Okay, so in the multiple choice, you may get a wrong part there. So conservative is maximin, yeah, or minimax, yeah. The same thing, yeah. This one is maximin and minimax. Okay, so in between, you can choose Laplace, equal probability, Horowitz, and so on. Okay. So with this, please do the assignment. Decision under uncertainty. Okay. Yeah. So if you want, you can discuss. Okay, what situation this currently you face that involve significant uncertainty? Yeah. Will you know the outcome of the uncertainty before or after the decision is made? And how you will make decision. So I want to summarize what we learned today. So in the IFN prioritization, okay, you have multiple attributes, right? And then in the second slide, how you make decision, we talk about classical technique, basically non-compensatory, okay, which is supposed to be solved by the MCDM, including IFN prioritization a while ago, okay? And this is a different method, okay? Decision under uncertainty. Now you can see the different table. Okay, instead of a criteria there, okay, the criteria is outside. Okay, what you have is now the state of nature. Okay, so I want you to do the assignment, and for next week, I hope you can read first decision under risk and the information. Okay, especially the information there, which is practically a little bit more difficult compared to the others. Yeah, and here, yeah, decision under risk, probability and base rule, and then is here, decision tree and value information, minimum AOL. Okay. This one is opportunity loss, it's similar to regret. Okay, so please read these values, slides, and the text here. There is a text here. Okay. So that you can get better prepared. Okay, and you can ask more questions. Okay. If you don't prepare, you will have a hard time to understand this part, especially the probability part. Okay, so better you read first before the class. Okay. Yeah. So thank you for today, and see you next week. Next week still have class, right? Correct?
Yes.
Okay.
Thank you,
you.
sir.
Okay. Thank you,
Yeah.
sir. Thank you. Good evening, everyone.
Thank you.
Bye.